I want you guys to write this down and actually look up there as well while you guys are writing this down. Imagine that there's two pots, okay? The first pot has water full all the way to the top. The second pot has water that's not quite halfway. So one of them has more water than the other one. The pots themselves are identical. The fire or the stove is going to have the same amount of heat coming out of it. I want you guys to think about this question, okay? Which one of these pots, pot A or pot 1 or pot 2, is going to boil faster? That's part 1 of the question. And part 2 of the question is, which one and why? So, which one's going to boil faster and why? I'm going to give you guys 3 minutes to. So let's go ahead and write that down. Energy in matter. Okay. Hey, who can tell me from the last sketch note what kinetic energy is? Anyone remember? Is it, or what do you think?
How much particles move?
Exactly. Kinetic energy, let's zoom in a little so we can see a little easier. Kinetic energy is the energy in movement. Well, what does movement mean? It's like when, things are moving. Now, last time we did this, I didn't tell you guys about the 3 different types of movement matter can do in particle forms. So I'll tell you guys those right now. The first one, so actually let's label these. Let's label these types of KE. What's KE stand for? Kinetic energy, exactly. Okay, types of KE. You guys will know these. The first one is particles can rotate. Now there's fancy names for these things, but I'm just going to tell you the ones that I use. Huh? You still need this? Yeah. Okay. So the first type of movement is called rotational. Another way to say that is to spin. Just like spinning. Spinning like that. That's rotational. Another type of kinetic energy, it's vibrational. This is like jiggling, like a piece of Jello. Has anyone ever poked a piece of Jello? You know how it just jiggles a little? And then the third type of kinetic energy, it's called translational. And that means moves. Now, there's a couple types of ways for it to move. I mean, you can go like really crazy, like a gas particle. Or it could be kind of slow, like a water molecule.
Well, for that, let's zoom into our book.
Okay. we're going to learn what thermal energy is. It says the sum of all energy of particles. But what does that actually mean? Well, it's not that hard. Let me just show you. Go to the middle of our page here and draw a pretty nice sized circle to represent our system. And then let's take that circle and let's put it inside of a pot that we're going to boil. Then let's set the water level here. Now inside of this pot, I want you guys to draw 7 circles, but make sure the circles are where I put them, not all random, because where they are matters. So let's put the first one at the very bottom here, almost touching the bottom of the pot. Let's draw another one a little bit higher. The next one we'll make even higher. The next one will be a little bit higher. And then we'll draw 3 more. 1, 2, 3. Okay. Before we get started, actually, I'll just tell you right now. I'll just tell you. It'll be easier. What do you guys think the definition of thermal energy is? We've never done it before, so I'll just tell you the definition. Thermal energy, or TE, thermal energy, go ahead and open it, is yeah, bring it here. What is that? Oh, okay. All right, thermal energy is all the kinetic energy added up in the system. Thermal energy is all the kinetic energy added up in the system. So this whole thing is a system. And when we add up all the energy that's inside of it, we call that thermal energy. Now, I have a question for you guys. If there's a flame on the bottom of this stove here, which particles is going to be hotter, you think? You think it's going to be the particles up here or the particles down here? Talk with your friend. Figure it out. What do you guys think? Which is going to be moving faster? The ones that are at the top or the ones that are at the bottom? Yeah, exactly. Because it's closer to the fire. It's probably going to be the bottom, right? So for that reason, let's go ahead and write some numbers down. We'll make up some numbers. So this one will probably be like kinetic energy of 6. Let's make this one 5. Let's make this one 4. Then 3. And then let's make the ones at the top all ones. All right? I want you guys to go ahead and take these movement types and put them in here. Which ones do you think are going to fit? So I'll put some rotational energy here. Now this definition right here, it tells us how to find the thermal energy of a system. I have given you all the information you need to find the thermal energy of this system right here. Can someone tell me a number that is the thermal energy of this system right here? You'll have to do some math. Do it on your own, and then I'll come check your pages.
2.
All right, basically, all you have to do to find the thermal energy of this system is to add up all the kinetic energy of the system. So let's do it right now. So we have 6 plus 5 plus 4 plus 3 plus 1 plus 1 plus 1. What does that equal?
21.
So the so the thermal energy of this system is 21. Hey, is there a reason why you guys are you guys getting distracted? You sure? Okay. Because there's a couple of kids in the back that would love to sit right there. Let's do temperature. Temperature. Do you guys still need this? Do you guys need this? No? Okay. So temperature is the average KE in a system. To find that, all you have to do is add up all of the in a system and then divide it by the number of particles. When you guys do chemistry in high school, this is how you guys will find temperature. You guys will be able to calculate the number of particles of certain elements, and then using temperature and how certain elements react to other processes, like physical or chemical changes, you'll be able to do a lot of different interesting things with it. All right, so another way to say this is to say that temperature equals thermal energy divided by number of particles. So TE is 21. And then how many particles are in this system?
7.
Yeah. And so there's 7 particles. So what is 21 divided by 7?
3.
Yeah, 3. So the temperature is equal to 3. Pretty chill, huh? All right, we got 6 minutes. We're pretty much done with this. And heat energy is simply the energy that is transferred. There's 3 different types of heat energy. So we'll write that down. 3 types of heat energy. And then we'll talk about what each of these are. Yeah, well, actually, let's do it right now. The first one is called conduction. Conduction happens when energy is transferred without translational kinetic energy. Otherwise known as not moving. So the way that happens is you'll have a particle, and another particle, and another particle, and another particle, like that. This one will vibrate, and it'll bump into this one. It'll stay in place. It's not going to move. And then the energy will transfer from here to there, to there, to there, just like that. The thing that makes the energy transfer is the bumping or the jiggling. So we'll say that the jiggling of the particles bumping into each other makes the heat transfer. It's a pretty simple idea. So, like, imagine like you have this is jiggling like this. Once bumps into over here, and it just moves on and on and on. Can you get the door for me, Joel? Thank you so much. Okay, let's keep it moving. The next type of, well, do you guys need this still?
Yeah.
Okay, I'll leave this here. We'll go to the next one. The next type of heat energy is called convection. Thank you so much. I'll go bring it to her today. Have a great day. Convection is the matter moves. Matter moves. So let's say we have a particle. It's jiggling, it's rotating, and it's also moving. If this high energy molecule or particle moves from here to here, the heat goes from this area to this area. And that's called convection. All right, the last one is over here. We're going to move it. Is radiation. And radiation is a good example of requiring no matter. No matter required. So in this example, we have the sun, like that, and we'll have the earth over here. The sun generates heat through a process called nuclear fusion. And when that process happens, it creates electromagnetic waves, and the waves can travel through space, and it can hit, some of the waves can hit the earth. And when that happens, the earth gets warmer. And this is called electromagnetic radiation. Now, most of the radiation that comes from the sun is very safe, but there's like this really high energy radiation that comes to the earth as well. and those could cause damage to your cells. That's why you have to wear sunscreen. So depending on how fast the wave is, it can be coming as something that's harmless, like just heat, or it can be coming down as like something that can cause cancer.